Hello students, from this lecture onwards we are going to start a lecture series on special theory of relativity. Now there are a few basic concepts like if there are two frames of reference, one is moving with the velocity v with respect to another, then you can have these transformations. These are called Galilean transformations. Uh, Again, based upon these transformations, there is invariance of Newton's second law. So you know that force is equal to mass into acceleration. So if we consider the two transformations, that means we are considering this as an S frame which is fixed and S dash frame which is moving with the velocity v along the x direction. Then we can write this force as equal to m into d square x by dt square, and we can also write mass into d square x dash by dt square in the moving frame of reference. Now if you look into this equation, then we can see that d square x by dt square is equal to d square x dash by dt square. So these two, so that makes the second law of Newton's second law, that is force is equal to mass and acceleration. It is invariant in these two frames of reference, S and S dash, moving and fixed frames of reference. And then we will have the following postulates of sorry. There are a few postulates of STR. The first one is the laws of physics are equally applicable in all inertial frames of reference. So laws of physics, they apply equally in all inertial frames of reference. Inertial frame of reference is the one which is either fixed or is moving with a constant velocity. So this is the first law. Second law is that the speed of light in free space is given by speed of light in free space is c, which is equal to 3 into 10 to the power 8 meter per second. These two are the postulates of STR. Now if the velocity is approximately close to c, then we have the following transformations which are called Lorenz transformations. So we define a quantity gamma which is equal to 1 by 1 minus v square by c square, and so the transformations are as follows. So x dash is equal to gamma x minus vt, y dash is equal to y, z dash is equal to z, and t dash is equal to gamma t minus vx dash by c square. So these transformations are known as Lorenz transformations. This sign can be plus minus based upon the fact that whether s dash is moving towards s or it is moving away from s. If it is moving away from s, then it is a minus sign. If it is moving plus, then it is plus sign. Now based upon these, Lorenz transformation can be also be written in terms of a matrix. sign this matrix as a, this is the matrix. So the matrix is given in the following way. It is equal to gamma 0 0 minus I beta gamma 0 1 0 0, and that is 0 0 1 0. Then it is I beta gamma, once again beta is nothing but equal to V by C, and 0 0 gamma. So this is the Lorentz transformation matrix. So we can write the Lorentz equation as x dash is equal to gamma into x, where x dash is equal to the Lorentz transformation matrix into x, and this is nothing but x dash, y dash, z dash, and t dash, and this is x, y, z, and t. So this is orthogonal. The transpose is equal to the inverse. So we again define another type of vector. It is called a 4 vector, and we know that in STR, apart from the space coordinates, time is also important. So we defined a 4 vector called capital X vector, which is given as x, y, z, and I, c, t. And so what is the consequence of Lorentz transformation? There are two consequences of Lorentz transformation. One is called the time dilation. That is the difference between any two events in one frame of reference. In the moving frame of reference is related to the other by this quantity gamma. So time seems to be long. Time difference seems to get enhanced if it is in the moving frame of reference. So delta t dash is greater than delta t. And the other one is called length contraction. Where any length is enhanced by 1 minus beta square. So the length is also gets contracted. So if there is a length of certain measurement in the fixed frame of reference, it will get contracted if it is in the moving frame of reference. Next property that is coming from the Lorentz transformation is the addition of velocities. So if we define the quantity beta, which is equal to beta 1 plus beta 2 you may remember that beta is basically V by C. That means velocity with respect to the speed of light. So there are two frames of references. That means 1 and 2, both of which having velocities v1 and v2. So correspondingly they will have beta as b1 and b2. So the total beta, if they are moving with respect to another, is equal to beta 1 divided by beta 2 into 1 plus beta 1 into beta 2. This is another consequence. And next the consequence is the when we are treating with mass, energy, and momentum. So Lorentz transformation has also got an effect on these. Like the mass is now, so if m0 is initial mass and the rest frame of reference is called the rest mass, mass gets transformed into mo into gamma. It is mo divided by root over 1 minus beta square. This is the new mass. And also the rest mass, if we consider, initially it was E is equal to m0 c square. This is the rest mass. So if we consider it as E0, so if there is a free particle and we want to find out the total energy of that free particle, so it will be a rest mass multiplied by the kinetic energy. So we write E is equal to T plus m0 c square, and we know that the mass has now changed to mc square in the moving frame of reference. It's no longer in E0, it's in E here, and T is the kinetic energy. Also, if we consider the momentum, then we know that P is equal to mv, so obviously it's now P is equal to m, so m is, as we have said, m is equal to m0 gamma into v. We can write it as beta into c. So the total energy is now equal to p square c square p square plus m0 square c to the power 4, and Cp is equal to beta into E. So we can write c square p square is equal to t square plus 2t m0 c square. The next is the transformation of angles. So tan theta dash is equal to sine theta divided by gamma cos theta minus beta by b0. This is the new angle. And also you can write in terms of, this is theta dash in terms of theta. You can also write theta in terms of theta dash. So this tan theta is now equal to sine theta dash into gamma into cos theta dash minus b by b dash. So these are some of the effects of Lorenz transformation.